So let's take a look at another example using the same distribution for heights. So again, heights are normally distributed, so immediately draw yourself that bell-shaped curve with a mean of 64 inches and a standard deviation of 3 inches. So go ahead and draw the distribution that shows the heights that are 1, 2, and 3 standard deviations from the mean. And then below that, write down the corresponding z-scores. Okay, so question B says, what is the probability that a randomly selected female from the United States is going to be between 62 and 67 inches. So again, here, just mark where 62 inches is and 67 inches. And again, the probability, so here, the probability that a randomly selected female has a height between 62 inches and 67 inches is going to correspond to the area under the curve that I'm shading in red. So we always associate areas under the curve with the probability, okay? All right, so how do I calculate this probability? I'm going to show you first how to use the z-table, and then I'll show you how to use your graphing calculator. So if you're using the z-table, the first thing that we need to do is convert 62 inches and 67 inches to its corresponding z-score. And so from part A, we already did that. We said that when x is 62 inches, the z-score is negative 0.67. So this is negative 0.67. And if we take a look at our sketch here, you don't really have to put this into the equation. You can just see that a height of 67 inches has a z-score of positive 1. So we can see that it has a z-score of positive 1. So now let's go to the table and take a look at how we would use the table. So recall in part A, when we converted 62 inches to a z-score of negative 0.67, and then we went to the negative side of the z-table, we found that the area to the left, so I'll shade that in green here, the area to the left of a z-score of negative 0.67, we found out that that is 0.2514. Okay, now the question that we're trying to answer is we're trying to figure out what is the probability that a randomly selected female is going to have a height between 62 and 67 inches. So that's going to be the shaded area that is shaded in red. So to figure that out using the z-table, I need to figure out what is the area that is to the left of a z-score of 1. So I'll shade this in blue. So if we, let me go to my highlighter. If we take a look at a height of 67 that has a z-score of 1, the area, when we go to the z-table, is going to be given to us as the entire area that's shaded in blue. So let's go to the table and look for a z-score of 1. So that's going to be 1 point, so this row here, and then the first column, 1.0. So that has a corresponding area. So in blue here, that area is 0.8413. Well, I hope that you guys will agree with me that the area of the red region is equivalent to the area of the blue shaded region minus the green shaded region. So if I wanted to know what is the probability that a randomly selected female has a height between 62 and 67 inches, to calculate that, I would take the area that is in blue, so that's 0.8413, and then I would subtract the green shaded region, which is 0.2514, and then that will give me the red shaded region. So that gives me 0.59. So the probability that a randomly selected female is going to have a height between 62 and 67 inches is approximately 59%, or 0.59. Okay, so now let's take a look at the same problem where we want to know what is the probability that a randomly selected female is going to have a height between 62 inches and 67 inches. And so again, making a sketch of that bell-shaped curve is going to really help you also use your calculator. So to use your calculator, you're going to go back to second bars, which is going to get you to the distributions. And again, here we're going to use normal CDF. So you always want to use normal CDF anytime you have a normal distribution and you're trying to calculate the probability when you have your given values. Okay, so you have your x values and you're trying to find the probability. So your calculator is always going to ask you to put in a lower bound and an upper bound. So here, hopefully you can see that 62 is the lower bound or the lower limit of the red shaded area under the curve, and 67 is your upper limit or the upper bound for the red shaded region. And so that's what you would write down if you were trying to show your work on your test. You would say that you use normal CDF, you're putting in 62, 67, and then you're going to also type in mu and sigma, and so sigma is 3 inches. And when you press enter, notice that it gives you 0.589. So this area here, the probability is 0.589, which hopefully you'll notice matches up with the same answer we got when we used the z-table.